APAB Calc. We are continuing in 2.2. Sorry, the last video ended a bit abruptly. So for our example 7, we're actually going to walk through what is listed as example 10 in your book on page 114. So I'm going to read you the example, but I wrote down the highlights that we need here. So at time t equals 0, a diver jumps from a platform, from a diving platform that is 32 feet above the water. And then there's a figure in the book, but you don't really need to see it. There's a platform, the diver jumps straight down. The position of the diver is given by S of t equals negative 16t squared plus 16t plus 32, where S is measured in feet and t is measured in seconds. So question A, when does the diver hit the water? And question B, what is the diver's velocity at impact or at entry when the diver hits the water? Okay, so this is actually an algebra question, okay? So when does the diver hit the water is an algebra question. Hitting the water, right? Hitting the water would mean that the position above the water or the position above the ground would be 0, right? So height would be 0. So in this case, S would be 0. So we're saying when is 0 equal to negative 16t squared plus 16t plus 32? To solve this, you're going to need to factor. Or use the quadratic formula, but honestly, factoring is way easier here. There is a GCF of a negative 16. If you take that out, you'll be left with a t squared minus a t minus a 2, right? So 0 equals negative 16. T squared minus t minus 2 is going to factor into t minus 2t plus 1. So either negative 16 is 0, which is a lie. That's not possible. T minus 2 is 0, which would be t equals 2. Or t plus 1 equals 0, which would be t is negative 1. So this answer is not in the domain of the problem, right? Because the domain of the problem is that the diver jumps at t equals 0. So this model is only good for values after or equal to 0. So this is not a possible answer, meaning that this has to be my answer of when the diver hits the water. So my answer to part A is t equals 2, right? And 2 seconds if you want to put your units to be safe. The next question was, what is the diver's velocity at entry? Well, instantaneous velocity is found by doing the derivative of the function, right? So I have S of t is negative 16t, and that's the derivative of any function. It's the derivative of position. So negative 16t squared plus 16t plus 32. So my S prime of t is going to be negative 32t plus 16, right? Which means that my S prime at 2 is going to be negative 32 times 2 plus 16, which is a negative 64 plus 16. So I get negative 48 feet per second. And you might say, okay, well, why is it negative, right? Well, it makes sense that it's negative because the diver is moving down, right? So what you're going to find with velocities is that a negative velocity usually means moving down if you're talking about a particle that is moving up and down, right? So like if you're talking about a diver or you're talking about somebody climbing up and down a straight ladder or something like that, you're talking, then velocity being positive would be up and negative would be down. Velocity is a vector. It has a direction, right? It's not like speed, which does not have a direction. If you talk about something moving left or right, like a car driving, then positive velocity means to the right and negative velocity means to the left. And again, this is if we're talking on the x-axis in a two-dimensional world where we have x and y axes. Things get more complicated when you add a third variable, but that's why you take Calc 3, which is called multivariate. So for right now, everything we're doing can happen on an x and y axis in 2 dimensions. So negative velocity because the diver is moving downward when she enters the water, okay? Cool, so I did want to do a quick comparison. We can even use this diver as our example, right? So we just found, okay, so let's actually go ahead and spin this into an example 8, okay? Let's do a quick example 8 and just do a comparison between, so we already know that the instant velocity was S prime of t equals negative 32t plus 16, right? And so we actually know that at t equals 2, which is when the diver entered the water, right, her instant velocity was negative 48 feet per second, right? So my question is, what is her average velocity while she's in the air? So keep in mind, in the air means she jumps off the platform at t equals 0, she hits the water at 2. So when I say while she's in the air, we're talking the window from 0 to 2, right? Well, the average velocity from 0 to 2 would be s of 2 minus s of 0 over 2 minus 0, right? And those are all values that we can find using algebra. Like, this is actually an algebra level question. So I can find s of 2 minus s of 0. So s of 0 is actually really easy to find, and it's probably worth just having, like, doing this up here where we have a little bit of room. S of 0 would be 0 plus 0 plus 32. So great, right? And actually, here's the funny thing. We already know s of 2. We know s of 2 is 0, right? Because we know that she hit the water, right? So hit the water at 2. So it would be harder to plug in if we actually had to find it. We would just plug in 2 here to find it, but in this case we don't have to, because again, we know that she hits the water. So the average velocity over that time would be 0 minus 32 over 2, which is a negative 16 feet per second. So I want you to note the difference, right? Average velocity and instantaneous velocity are different, right? And it actually makes a ton of sense if you think about it, because if you've ever fallen off of anything, or if you've ever watched a ball drop, or if you're just aware of how gravity works, acceleration happens as gravity takes over, right? So something that starts at rest, like the diver, she started not moving. When she jumped off the platform, she accelerated. So as she fell, she picks up more velocity. Her speed increases, right? So that makes sense that her average velocity over the time is not as big as her velocity when she hit the water, okay? So I do, before we end this video, and this is the last thing in this section, I do just want to address a couple vocab things, because I said a couple of them right now that came up in passing, and I said them like it wasn't even a thing, but it probably is a thing, so we should talk a little bit about, so particle motion vocab. And we're going to talk about this again later in this class when we talk more about learning about acceleration and other stuff, but particle motion vocab. So let's talk first about the word initially. Okay, initially generally means that t equals 0, right? So if you hear the word initially, so because it's at the start of the problem. Okay, so if you hear the word initially, they might never tell you that t is 0, but that's what that means. The phrase at rest means that the velocity is equal to 0. Okay, it means you're not moving, your velocity is equal to 0, right? Let's see, other things to keep in mind. Those are the two big ones that you're going to see, right? Oh, so hits the ground, right? Hits the ground or hits the water or something like that's going to come up, okay? And that basically means that the height, which is usually your position, is equal to 0, okay? Those are the big ones that you've seen so far, right? That have come up at all colloquially right now. There are other ones that are going to come up later. So let's, if we talk about moving right or up, right, either of those, that's going to mean that the velocity is positive, right? Moving left or down is going to be the code words that you hear when the velocity is negative, right? Let's see. We're going to talk later about things like speeding up and slowing down, but those are the big ones so far. So initially means t equals 0. At rest means velocity equals 0. Hits the ground means that the height or position is 0. If you're talking vertically, you can't really hit the ground if you're running on the ground, if you were running left and right. And then moving right or up is velocity being positive, moving left or down is velocity being negative. We're going to do a lot more particle motion later, but it's worth putting this out there now. This is another time when it's not an awful call to make some note cards, right? Like, just like we have our antiderivative rules, right? It's not a terrible life choice to put initially in quotations on one side and then time equals 0, like t equals 0, and put at rest in quotations on one side and put velocity equals 0 on the other. As dumb as it might seem to you right now, these are things that you want to quiz yourself on constantly, because when you hear a problem where in the first sentence they say the phrase, a particle initially at rest, okay? That was 5 words. A particle initially at rest. In those 5 words, I know a lot of stuff, right? So I know initially at rest tells me that v of 0, the velocity at 0, is 0. I can get that information from those 5 words, right? There's lots of other pieces of information that you can get from these words, but if you can't translate the words into what they mean mathematically, you're going to have a really hard time on this AP test. So please, please, please make a note card, right? Buy some note cards, lots of note cards, or cut up a lot of pieces of paper. Make a note card where one side says the word initially and the other side says t = 0. Where one side says at rest and the other side says velocity = 0, right? Please, please, please make note cards for these things, okay? I know it seems silly right now, but trust me, I've been doing this a long time. It's going to help, okay? So make note cards. Note card for this, note card for this, note card for this, okay? And quiz yourself often. Don't just have the note cards and then not use them. I promise you, if you know this vocab, you're going to have a much easier time doing well in calculus and calculus-related courses.